In this section, we'll talk about roots, radical, and rational exponents. You have seen a radical expression. So here, let's say we have a here, we have n. So in this expression, so this part, so this is our radical sign. Okay, so this part is, we call it radical sign. So this is radical sign. Okay, this n is a positive integer, we call it index. Okay, n is index, and the expression under this radical sign, we have a, and we call this a radicand. Okay, so we call this a, so this a is radicand, and all these combined together we call it radical expression. So everything combined, so all this combined together is radical expression. I missed a here. So we have index, we have a radical sign, we have a as a radicand, and all this combined together we have radical expression. Let's take an example. For example, let's say we have cube root of 4x squared. Now in this radical expression, which one is the index? What is the index? Index is 3. Okay, what is the radicand? Everything under the radical sign is radicand. So whatever we have, you have under this radical sign is radicand. So 4x squared is radicand. Okay, not only a number, it can be whatever you have under that radical sign is radicand. Okay, for example, let's say we have again a plus 2 cube. Okay, now in this expression, what do we have as an index?
2.
Now if there is no n, or like if there is nothing, then we understand it as a 2. This is a square root, right? So this radical sign, we call this radical sign as a square root. Okay, it does have an index 2, but we do not write in general. Okay, if you write 2 here, it's not wrong, but in general you are not required to write index if it is a square root. Now for this radical expression, what is the radicand? A plus 2 cubed. Yes, so everything under this square root is radicand. Okay, so this is the radicand. Okay, now so here we have to find the nth root of a number. So let's start with cube root of 64. So here we have cube root of 64. Now you have to think of a number. So our index is 3, radicand is 64. Now you have to think of a number whose cube is 64. What is that number? 4. Okay, so cube root of 64 is 4. Okay, now we have a fourth root. Okay, so we read this as a fourth root of 16. So we have to look for a number whose fourth power is 16. 2. Okay, so this is 2. And the next we have a fifth root. Okay, so this is the fifth root of negative 32. Our index is 5. Now we have to think of a number whose fifth power is negative 32. Negative 2. So negative 2. Does anyone have a question here? Okay, so next here we have some rule for simplifying this radical expression. Okay, if we are multiplying the two radical expressions. So we have a radical expression with an index n. Okay, radicand is a, and the next radical expression is the index is still same n, and our radicand is different than a, b. So here you have to keep in mind, if we are multiplying two radical expression with same index, so our index is n, so our index is still same. Okay, index has to be same, index is same, then the product is, you have the radical sign, the index remains same, now you only multiply the radicand a and b, so a times b is a b. So you can't multiply any radical expression. To multiply a radical expression, the index has to be same. Okay, and if you have an index same, to multiply, you are multiplying the radicand only. Let's take an example. So we have square root of 2 times square root of 3. Both of these radical expression has a same index, right? 2 is the common index. Now in order to multiply this, you write down your radical, index remains same. Now you are multiplying 2 and 3. 2 times 3, we have square root of 6. The index has to be same. But instead of this, if you have something like square root of 2 times cube root of 3. Now here, you can multiply this only with your calculator. We do not use this rule. Okay, so this rule applies only when our index is same. Okay, now this radical expression has an index 2, it has an index 3. Okay, so you can multiply, if you are asked to multiply, use calculator. But we are not using this rule. Okay, so this rule applies only when our index is same. In the similar way, so if we are dividing our radical expression, so we have a radical expression here with an index a, radicand is a, and dividing this radical expression by another radical expression with an index n, which is same, and a different radicand, then this is similar to the previous one. You have the radical sign, same index. Now you are dividing radicand a by radicand b. So this is a divided by b. So let's take an example. Let's say we have fifth root of 25 divided by fifth root of 5. What is the one common thing in this radical expression? Same index, right, which is the 5. So 5 is the common index here. Now in this case, you write down the radical sign, you're gonna have the same index 5. Now you are dividing 25 by 5. So 25 divided by 5, and this is fifth root of 5. Okay, so this is the final answer. So we are using this rule only when we have the common index. If you have a different index, you are allowed to use calculator. Okay, now we do have more example here. Okay, now here, so so here it tells us to rationalize the denominator. Okay, before this rationalization, so let's do part B. Okay, so this is not what we covered now. So let's do part B. We are dividing, this is the radical expression in the numerator, by another radical expression. Okay, and both of these radical expression has a common index 3, and if this is the, since this is the common index, you write down the radical expression, index remains same, and you are dividing 10 by 3, and this is the final answer. You can have fraction. Okay, if you want a decimal, yeah, you can also, but this can be the final answer. Any question? So make sure to check the index. Okay, before you multiply, before you do a division, the index has to be same. And this is similar if we are, now when we are adding or subtracting, I think we should have that. Okay, let me check that. If not, I will. So do we, okay, so here addition, does it tell us anything about the adding radical expression? Bless you. Okay, nothing. Okay, so let me add few more thing here. Now, if we are adding or subtracting, we have to have a like terms, right? Now, the two radical expression, so let's say we have square root of n a, okay, and square root of n, sorry, not square root, nth root, okay, so this is the nth root of a and we have nth root of b. Now these two radical expression will be like terms if their index are same, we have a same index, and if they have a same radicand. Now do we have a same radicand here? So for the first radical expression, what is radicand? A is the radicand. For the second expression, what is radicand? B is radicand. Okay. Now these two are not same, so we can't add or subtract this expression. Let me take an example. So for example, let's say we have square root of 2 plus square root of 2. Now, are these two like radical expression? Now, do they have a same index? Do they have a same radicand? Now, if this is the case, then we can add. And it's the same thing for subtraction, okay? Now, how we add? So we always find a number in front of this square root of 2, right? Which is 1, right? If it's nothing, there is always 1, okay? Now, both of these expression has a square root 2 as a common. So let's factor out square root of 2. And we end up getting 1 plus 1. And this give us, okay, just let me write down that 2 in front. So 2 times square root of 2. So this is the final, okay. So in the similar way, so if we have something like 2, okay, cube root of 3 minus 4 cube root of 3 plus 5 cube root of 3. Now all these radical expression are like, right? They all have a same index. See, the index is exactly same, 3, and their radicand is same, 3, 3, 3. If this is the case, now we can add, multiply, and now you can just factor out or you can skip here. So you can take this expression as a x, okay, like just take this as a x on your mind. So if this is a x, then this is 2x minus 4x plus 5x. And what is that equals to? So 2x minus 4x, that is minus 2x. Minus 2x plus 5x is 3x, right? So this is 3. And in our case, x is cube root of 3. So if you have a like, so 2 minus 4 is minus 2 plus 5 is 3. And do not forget this radical expression. So make sure to check index and radicand whenever you are adding or subtracting. But to multiply or divide, only one thing we need is common index. Okay. So here, so in order to multiply, we must have a index common. That is enough. We do not need radicand to be exactly same to multiply or divide. Okay. The only one thing we look is the index. Okay, now the next here, so if we have n, which is the index, as an odd index, then okay, the nth root of, so I'm just rewriting this. So if we have our n as an odd index and nth root of a to the power n, this is equals to a, and our a can't be equals to 0. And let me take an example here. So example B, what is the index for example B? 3, right? And 3 is odd. And is, so what is a here? Now here we have to rewrite this number, okay, in an exponent form. So how can we rewrite 125 in exponent form, in a power of some number? So this is, let me just copy the radical sign. So we have 125. So how can you rewrite 125 as a power of some number? 5 to the third, right? So 5 cube. Okay, so let's rewrite 125 as a 5 cube divided by, what about 108? 4 cube. Okay, 4 times 4 is 16 times 4, that is 64, not 4. 108. Now, okay, if now there is a way to find that. Okay, so let's find the prime factor of 108. Okay, let me do here. So we have 108. What are the prime numbers? Can you just tell me one smallest prime number? 2, right? So 2 is the smallest prime number. And what is the next prime number? So prime numbers are the numbers which are divisible by 1 and by that same number. Okay, like 5. We can divide 5 by 1 and 5 itself. 7. We can divide 7 by 1 and 7 itself. What about 9? Is 9 prime number? We can divide 9 by 1, 9 and 3, right? So there is 3 which divides 9. So 9 is not a prime number. So to be prime, it has to be a number which is divisible by 1 and by itself. Like, what about 13? Is it a prime? 13 is divisible by 1 and it is divisible by itself. Do we have any number that divide 13? No, right? So 13 is a prime. So for 108, we can find the, we can rewrite 108 as a product of prime factors, okay? Product of number that divide 108. So let's start with 2. So if we divide 108 by 2, so if we divide by 2, what number do we get? 2 divided by 108 is 54, right? Now we have one prime factor here. Now let's do the, now is 54 prime number? No, right? So let's divide 54 by the smallest prime number, which is 2. So 2 divided 54 is 27. Now is 27 prime number? No, so we are not done it. So we can divide 27 by the 3, right? 3 times 9 and 9 is 3 times 3. So here 108 is, we can rewrite 108 as a 2 times 2 times 3 times 3 times 3. So 2 times 2 times 3 times 3 times 3. And this is the prime factors. Okay, all these numbers are the prime factors, like, of 108. Okay, we rewrite 108 as a product of prime factor. Now the next here, so how many 2 we have? 2, right? So we can we rewrite 2 times 2 as a 2 square? Okay, in the similar way we have 3 times 3 times 3, and this is same as 3 cube. Okay, so 108 is equals to 2 square times 3 square. Okay, so let's write down that. Okay, so our 108 is 2 square times 3 cube. So there is not a number whose cube is 108. Okay, not a whole number. Okay. Okay, next here we have a 5 cube. This has a exponent 3, okay, and we have next number whose exponent is 3. Now if you have this, you can always write this number outside the radical sign. The index is 3. Okay, do not forget our index is 3. Okay, here the index, the exponent of a radicand is 3. The exponent of a radicand is 3. Now we can just write this 5 and 3 outside the radical sign. And the reason here is the index and the exponent of a radicand is same. Okay, it has to be same. So here on our rule, so what we had nth root of a to the power n. Our index is n. The radicand has an exponent n. And if this is the case, then you can write a outside the radical sign, okay, and inside the radical sign we are left with 1, and any power, any root of 1 is always 1, right? Like a fifth root of 1 is 1, square root of 1 is 1, so you can simply write this as a, okay. I think you might have been cancelling. Do you used to cancel like this, nth root and a? Is that how you used to solve? But it's not really cancelling, okay. So here make sure to have the index same and exponent of a radicand same. So in our case we have 5 with a exponent 3 and this 3 with a exponent 3. This 3 and this index 3 is same, so 5 we have in the numerator, so let's write outside, and in the denominator we have 3. Now we still have the radical sign because this radicand does not have a exponent 3, so it stays inside. In the numerator there is nothing, means we have 1 divided by 2 square. If your radicand has a same exponent as the index, it come outside, okay, and if it does not have a same index, it stays under that radical sign. Like here, this 2 square, the exponent is 2, which is not same as 3, so it's inside, okay. This we have a 3 cube whose exponent is same as index, so it comes outside, and when it comes outside it does not bring its exponent, okay, so the exponent part is gone. 5 cube has a exponent cube and index is cube, so 5 only 5 comes out, okay. So this is how we can simplify. Now for part C, so we have square root of x to the power 5 y to the power 7. Now let's rewrite x to the power 5. How can we rewrite x to the power 5? X to the power 5 is x time x time x time x time. How many times we need to multiply? 5 times, right? So we have 5. Y to the power 7, y time y time y time, so that's 4 5 6 7. What is the index for this radical expression? 2. Now our target here is we have to rewrite our radicand as an exponent of a 2, okay, so that we can know what to bring outside. Now we have x times x, so how can we rewrite this? X square, right? So this is x square. We have x times x, this is x square, so x square, and the x remain as it is in the similar way. So let's combine and have an exponent 2, okay. So y times y, which is y square, y times y, which is y square, y times y, which is y square, and we have y by itself. Once you know the index, you always try to rewrite the radicand with that index as an exponent, okay. Our index is 2, and because of that we choose our exponent to be 2, okay. Now once we have this, now one more question. So here we have so many expressions. We have now what is this? So here, so what sign do we have in between every term here? Multiplication. Do not forget that, okay. Your radicand has to be in a product form. So let me complete that, then I will just do one more example here. So here this expression x square, this expression, this expression, this expression, and this expression, all these have exponent which is same as index 2, so these come outside. So x times x, so from here you take y, from here y comes out, from here y comes out, and under the square root, so what are left? So we have x and this y are left. So x times y. So let's simplify. X times x is x square, y times y, that is y cube square root of x y. And this is our final answer. So here you can skip, bless you, you can skip like a step, the very first step, okay? So you are not required to have every step. So here at if you want, you can skip the first step and this step as well, okay? But if you need help, yeah, if you have confusion, yeah, make sure to write every step, okay? But once you are like a kind of like a perfect, then yeah, you can always skip these steps. Okay, now here for example, let's say something different here. We have square root of a square plus b square. Now what is the index here? 2. What is the radicand? Our radicand is a square plus b square. Now what sign do we have in between a square and b square? Plus. Now since we have a plus, and if it is, and this is same for minus, now in this case you can't bring a and b outside the radical sign. If you write this is wrong, you can't, okay? It has to be in a product form. Instead of this, if we had something like a square times b square, now this is a times b. So it has exponent 2, which is same as index. It has exponent 2, same as index, and in between these two expression we have a product. So we can get rid of radical sign here. But in the first case we have a positive here. We have a positive. We can't, since we have a positive, or if you have a negative, you can't use this rule, okay? We use this rule when you have your radicand in a product form, okay? It has to be in a product form, and in order to bring the expression outside the radical sign, the index has to be same as the exponent of a radicand. Okay, so now let's go back to number A. So we have 75. Now let's start by writing 75 as a product of prime factor like we did for 108. So 75. So what is the smallest prime number that divides 75? Is that the smallest one? You always start with the smallest number, 3, right? So let's divide by 3. So 3 times 25 is 75. Now the smallest prime number that divides 25 is 5. 5 times 5 is 25. So our 75 is 3 times 5 times 5. Okay. So let me write down that. So here, so our 75 is 3 times 5 times 5. What is the index? Index is 2. Now our target is writing this factor as a exponent 2. So we have only 1 3, so we can't add 1 3 here, so 3 remains as it is. Now for 5 times 5, how can we rewrite this 5 times 5? 5 times 5 is 25, but that's not what we want. What do we want? 5 square. So we want to write as a 5 square. This 5 square has an exponent 2 and index is also 2. So this 5 comes outside. So you write down 5 outside the radical sign. Now this 3, it does not have has an exponent 2. So it has to stay inside the square root. So this is 5 square root of 3 is same as the square root of 75. That's how we simplify. Okay. So you start with prime factor. You start with writing a radicand as a product of prime factor. Then you have to make a combination. And that depends on what index you have. Okay. Okay. Any question? All right. Let's go to the next one. So here we are simplifying. So we are adding, subtracting radical expression. Okay. Now, can we add square root of 48 and square root of 27? Okay. without simplifying, we might, okay? Now here, is it possible for us to add these two radical expression? There is a two condition it has to satisfy. Do they have a same index at first? What is the index? Next thing, do they have a exactly same radicand? First one has a radicand 48, the second has a radicand 27. So we can't add here, okay, unless we simplify. And it's similar for the square root of 12. Okay, but let's simplify this radical expression like we did for number A here. Okay, so we have 48. So let's start by writing 48 as a product of prime number. Okay, so 48. So let's start. Okay, what is the smallest prime number that divide 48? 2, right? So 2 times, is it 24? And you are not required to show this, okay? If you can do this on your head, that's fine, okay? 24 is 2 times 12. 12 is 2 times 6, 2 times 3. So our 48 is 2 times 2 times 2 times 2 times 3. So that is 2 times 2 times 2 times 2 times 3. So this is 48. Let's do the same thing for 27. And 27 is 3 times 3 times 3, right? So 27 is 3 times 3 times 3. Now, how can we rewrite 12 as a product of prime factor? 2 times 3, so 2 times 2 times 3, right? 2 times 2 times 3. So 27, that is, so 3 is the smallest, so 3 times 9, and 9 is 3 times 3. And if you have something different way of finding the prime factor, you can still use that, okay? So it's not that you have to use this one. Okay, now our index is 2, okay? So let's make a pair of 2, okay? So this is one pair, this is other pair. So this is one pair. So this is one pair. So we have to make a index is 2. So we have to make a pair here. Okay. Now let's rewrite. So this is now what is our next step? So 2 times 2 is 2 square, and this 2 times 2 is 2 square, and 3 it is as it is, plus 3 times 3 is 3 square, and that this 3 has a pair, so it remains as it is, minus 2 times 2, that is 2 square, times 3. Now you take out the every number that has a exponent 2, okay? So this has an exponent 2, so it comes outside. It has the exponent 2, so it comes outside. It has exponent 2, it come outside. It has exponent 2, it come outside, okay? So we have 2 times 2 square root of, what is left? 3, plus, so these 3 come outside, square root of 3, minus, so these 2 come outside, square root of 3. So this is the key step here. Okay, any question up to here? Now, do we have same index and same radicand? In each radical expression, do you see same index and same radicand? Yes, right? So each has an index 2 and radicand is 3. If this is the case, you are simplifying the number in front of this radical expression. So this is 2 times 2. So let me write down this as a 4. Okay. So let me do that in the next step. So this is 4 square root of 3 plus 3 square root of 3 minus 2 square root of 3. Now to simplify, you simplify just the number in front of this radical expression. So 4 plus 3, that is 7, minus 2 is 5. And do not forget the square root of 3. So 5 square root of 3 is the final answer. 5 square root of 3. Any question? Okay. Now the next here we have a part B. Okay, so in part B we have to multiply this expression. So let me just rewrite the question. So we have 3 plus square root of x times 4 minus 2 times square root of x. Okay, so let's multiply here. So we pick 3, or you can start from square root of x, and you multiply each term from second expression. Okay, so 3 times 4. So 3 times 4. The next 3 times negative. So this is 3 times. Since we have a negative, so let me write down this inside the parenthesis. Okay, 3 times negative 2 of square root of x. Now you do the same thing for next expression. So you use the square root of x, multiply 4, then you multiply negative 2 square root of x. So this is, so we have a plus in front of square root of x. So plus square root of x times 4 plus square root of x times negative 2 square root of x. Okay, any question on this part? So here we have a product sign. Okay, so here we have a product sign here. That's why we multiplied. Okay, so you pick one term and multiply every term from the next second part, and you do the same thing for the square root of x. Now 3 times 4, this is a very easy, right? So this is what we know. Now here we have a 3, we have to multiply 3, and we have to multiply negative 2 square root of x. And we also need to multiply positive, this positive and negative. So positive times negative, we get negative, right? Now what is 3 times 2 square root of x? Does this 3 has a radical sign or radical expression? It does not, right? So this is a whole number, so you multiply this whole number 3 and you multiply this whole number 2. So 3 times 2 we have 6 and square root of x as it is. You can just think square root of x as like a. So if it was a, then 3 times negative 2a is negative 6a, right? So we have negatives. I'm sorry? No, we multiplied. So here we multiplied this positive sign and negative sign. So positive times negative, we have negative. Okay, then we have this 3 and 2 as a whole number. So we multiply these two 6 and square root of x as it is. Now very similar way we can simplify the next expression. So we have square root of x times 4. 4 is a whole number, and what number do we have in front of square root of x? We have 1, right? So 1 times 4 is 4 and square root of x. You can replace your square root of x by some variable a or b. So let's say square root of x is a. So a times 4 is 4a, and we have 4a. But do not write a. So that's what you do on your head. Okay, so 4 times square root of x is 4 square root of x. Now the last expression. So we have a radical expression here and we have a radical expression here. And if you are multiplying radical expression, what we have to check? We have to make sure they have a common index. So positive times negative, that is negative. So this is going to be negative. Now this is square root of x and this is square root of x. They have a same index, right? So we can multiply. So we have, okay, just let me rewrite this. We have 1 here. Okay, so 1 times 2 is 2. Now you have a square root. Now you multiply the radicand, x times x, x times x. You can multiply radical expression together if they have a common index. Okay, Now let's see, let's look for the like terms. Are these like terms? What do you think?
Yes.
Yes, right? Same index, which is 2, same radicand x. So we have 12 as it is. Let me go back to the same. Now, how we simplify? So we have negative 6 plus 4. And what is that? Negative 2 and square root of x minus 2. So we can rewrite x times x as a x squared. So we have 12 minus 2 is square root of x. We have negative 2. Now, how do we simplify this expression? The square root of x squared is x. And why is that? So we have an exponent 2. Our index is 2. So we have x left here. And there is nothing under the radical sign. Nothing means it's not a 0, it's 1. Okay? And 1 times x is x. And this is our final answer. Okay. Now let's before we start the next topic, let's do some more examples here. Okay, so here we have, okay, I want you to try this, okay? Square root of 216 minus 4 square root of 24 plus 3. So I want you to try this. You can do it in a group, and if you need help, yeah.